All right, so my point right now is I'm going to show you a little bit about the remainder theorem. Now, I'm not going to prove it. I'm not going to show it to you. That's actually a pretty straightforward proof. If you want to see it, you go look it up in your textbook, all right? Oh, I bet you find another video here on YouTube that proves the remainder theorem for you. It's quite simple, and it's kind of neat, but I don't want to take the time for that right now. Of course, I just took a whole 30 seconds to explain why I didn't want to do that. But anyway, okay, so I got a polynomial. Px is a polynomial. Now, if I take that and I divide it by a binomial, so x minus k. K can be whatever you want it to be, okay? Any number, any real number. So I take that polynomial, I divide by a binomial, and the result is a polynomial, right? I don't know what that polynomial is going to be. It depends on what p was and what x minus k was, but I end up with a polynomial here. And then at the end, I got some remainder, which is written over x minus k. Now, you should have been practicing your long division, and so therefore, you should have an idea of what this means. You got this polynomial, x squared plus 3x plus 2, plus, and then whatever was left, whatever couldn't be divided, that goes over the x minus k there. So, we now got this for the remainder theorem, but the remainder theorem says this r can be found another way. R can actually be found by taking that k, right there, that one right there, that k, and putting it into the original polynomial, and that will actually tell you what that number is right there. Now this can be proven. You can see it. You can look in your textbook. You can look at other videos on YouTube, like I say. But I just want to show it to you today and show you how it works. All right? So this says use remainder theorem to find the remainder when this is divided by x plus 2. Okay, so now one thing that you could do is you could say, okay, I'm going to take x to the fourth minus 3x to the third, and I'm going to add x, I'm going to go minus 4, and then I'm going to go divided by x plus 2, and then you start doing your division. And then you get through this and you go, oh no, I forgot the x squared, and I got to start all over again. So then you have to take this off, and then you got to go plus 0x squared plus x minus 4, and then you do the whole thing over again. And I don't want to do that, I don't want to do that either. So here we go. What we're going to do instead is use the remainder theorem, which is the point. So we're going to do P of, now note that this is x plus 2. That's not what we want. It needs to be x minus k. So x minus negative 2. So P of negative 2 equals negative 2 to the fourth minus 3 times negative 2 cubed plus negative 2 minus 4, and negative 2 to the fourth is 16, negative 2 to the third is negative 8 times negative 3 is plus 24, minus 2 minus 4, and that gives me a total of 34. And so the remainder would simply be 34. Okay, and I can show that to you. Another way to do this is through synthetic substitution, which is an offshoot of synthetic division. Okay, if you write down the coefficients, the x to the fourth coefficient, the x to the third coefficient, the x squared coefficient, the x coefficient, the constant there, and then we divide in negative 2, we bring down the 1. Negative 2 times 1 is negative 2. Negative 3 minus 2 is negative 5. Negative 2 times negative 5 is 10. 0 plus 10 is 10. Negative 2 times 10 is negative 20. 1 plus negative 20 is negative, no, watch this, negative 2 times negative 19 is 38. And 38 plus negative 4 is 34. And so I did it without having to do any of those silly power things, okay? So you can get it that way as well. This is also your remainder. What this actually is this is your quotient. Q of x is 1x cubed minus 5x squared plus 10x minus 19, and your remainder is right there. It's plus 34 over x plus 2. And so 34 is your remainder. It's also what's left over there. This then also makes sense that if you get 0, that means there was no remainder, and it's a factor. It divided it evenly. All right, well, I think that's enough of the remainder theorem. That's the basic idea. That's all I wanted you to see here, is that you can use the remainder theorem to get that number just by substituting that, or by doing your synthetic division, substitution, whatever. All right, so that's all I got for you, and you can watch another video if you want.